You are tuned to Iri-e-learning and I am your host, Teacher. In this mole concept lesson, we will briefly introduce mole concept. Check the description box for links to all the videos related to this unit. By the end of this lesson, we should be able to define mole and molar mass and distinguish between relative mass and molar mass. Let us begin with a definition of the mole. What is the mole? The mole is a name used to represent a specific quantity of items. For example, consider the term dozen, where 1 dozen represents 12 items. Likewise, 1 mole is the term used to represent a particular number or value. Do you know what that number is? Well, the very long number appearing on the screen represents 1 mole. This number is so long that it would be challenging to work with when doing calculations. Can you imagine writing this number out each time when needed in a calculation? So we simplify this number by expressing it in standard form, also known as scientific notation. When a number is expressed in standard form, it is written in the format a times 10 to the power of n. A, the front number, is typically a number that is greater than or equal to 1, but less than 10. N is the power or index of 10, and it tells how many times the front number A is multiplied or divided by 10. Note that n can have a positive or negative value. When the number to be expressed in standard form is large, much like the number that represents 1 mole, the value of n is positive. However, the value of n is negative for decimal numbers occurring between 0 and 1, such as 0.00025. To express a number in standard form, we must first locate the decimal point. Looking at this large number, it would appear that it doesn't have a decimal point. However, it does. Note that for any whole number, the decimal point exists after the last digit, even though we do not write 1 there. So for this activity, we will write a decimal point at the end of the whole number representing 1 mole. Once we have located the decimal point, the second step is to move the decimal point until it occurs between the first 2 significant digits of the number. And the first 2 significant digits for this number is 6 and 0. We will therefore move the decimal point, jumping 1 digit at a time until it reaches between the first 2 significant digits, 6 and 0. It is important to count how many times the decimal point moves until it reaches its new position because it gives the value of n. Remember, the value of n is the power of 10 in the standard form notation. Let us count together as the decimal point moves past each digit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. That was a mouthful. Since the decimal point moved 23 times to get to its new position, the value of n is 23. The third step involves deducing the value of a, which is the front number. Direct your attention to the new location of the decimal point. As you can see, a decimal number has been created, 6.023, which is the value of a. We erase all the trailing zeros because they are no longer of value. This number, 6.023, is greater than or equal to 1, but less than 10. Therefore, the number representing 1 mole expressed in standard form is 6.023 times 10 to the 23 power. This number that represents 1 mole is also called Avogadro's number or Avogadro's constant. You must try to remember this number because in science, 1 mole of any substance contains 6.023 times 10 to the 23 particles. And these particles can either be atoms, ions, molecules, electrons, protons, or neutrons. Note that the word mole is abbreviated MOL. It's not much of an abbreviation, but it works for us. We will continue with the first learning objective by defining the term molar mass. We will use the periodic table to assist with defining molar mass. Let us use the element carbon as an example. The mass of carbon is 12. Therefore, if a sample of 12 grams of carbon were measured out, the element sample would contain 6.023 times 10 to the 23 carbon atoms. Since 6.023 times 10 to the 23 is 1 mole, then 12 grams of carbon is the mass of 1 mole of carbon. Let us take a look at a second element, magnesium. The mass number of magnesium is 24. Therefore, if we were to measure 24 grams of magnesium, the element sample would contain 6.023 times 10 to the 23 magnesium atoms. Once more, since 6.023 times 10 to the 23 is 1 mole, then 24 grams of magnesium is the mass of 1 mole of magnesium. The same principle applies to any element we choose on the periodic table. Consequently, the molar mass is defined as the mass in grams of 1 mole of an element or compound. The unit for molar mass is grams per mole, which is written either as g/mole, where the slash means per, so grams per mole, or it can be written as g/mol to the -1, where -1 applies to the mole, meaning per mole. You can use either format. There is no stipulation on using one over the other. Whichever you're comfortable with, go ahead and use that notation for writing the unit grams per mole. Going back to the initial examples, since the mass of 1 mole of carbon is 12 grams, the molar mass of carbon is 12 grams per mole. Similarly, the mass of 1 mole of magnesium is 24 grams. Therefore, the molar mass of magnesium is 24 grams per mole. Here are some points to keep in mind. The molar mass, the mass of 1 mole of atom of an element, has the same numerical value as the atomic mass or the mass number of the element on the periodic table. Always remember the unit for molar mass. It's grams per mole, which is either written as g/mole or g mole to the power of -1. Relative mass is another term we must be able to explain. There are 2 types of relative masses. The first is relative molecular mass, abbreviated RMM. The term relative molecular mass is used when calculating the relative mass of covalent compounds. The second is relative formula mass, RFM. This term is used when calculating the relative mass for ionic compounds. Recall that ionic compounds form formula units and not molecules. Just in case you have not yet reviewed the lessons on ionic and covalent bonds, you should follow up with those lessons when you have completed this one. Now, the relative mass is the ratio, hence we draw that ratio or division line, in which the mass of an element or compound is compared to 1/12 of the mass of carbon-12, which is 12 grams. Let us examine the definition of relative mass using a practical example. Say we choose the element nickel from the periodic table. The data shows that nickel has an atomic mass of 59 atomic mass units, which we equate to 59 grams. We now know that the relative mass is the ratio, and we're drawing that ratio line, of the mass of nickel to 1/12 the mass of carbon-12. Now we're going to substitute for the masses that we have in our equation. So we now have 59 grams, which is the mass of nickel, divided by 1/12 times 12 grams. 12 grams is the mass of carbon-12. In the denominator, we have 1/12 times 12 grams. So 1 times 12 is 12 grams divided by 12. As we know, any number divided by itself is 1. So we now have in our denominator 1 gram. Notice that the unit grams, G, appear in the numerator and the denominator. Consequently, the units cancel each other. We are now left with 59 divided by 1, which is equal to 59 without any units. You may have already noticed that the relative mass of nickel, which we are finding, is actually the same as its atomic mass or the mass number given on the periodic table for this element nickel. Therefore, we can conclude that the relative mass of an element or a compound is simply the value of the mass of the specific element or compound without any units. So when you see the word relative, as in relative mass, it means it has no units for mass. So it's just the value without any units. For the final lesson objective, we will distinguish between molar mass and relative mass. Molar mass versus relative mass. Molar mass is the mass of 1 mole of an element or compound. The molar mass has units of grams per mole, which can be written or denoted as G/mole or G mole to the power of -1. Whichever notation you choose to use, it means the same thing. On the other hand, the relative mass is a ratio. It is the ratio of the mass of the element or the compound compared to 1/12 the mass of carbon-12. The relative mass has value but carries no units. Here are the lesson summary points. 1 mole of any substance contains 6.023 times 10 to the 23 particles. These particles can be electrons, atoms, molecules, ions, etc. The number representing 1 mole is called Avogadro's number or Avogadro's constant. The mole is abbreviated as MOL. The molar mass is the mass of 1 mole of a substance given in units of grams per mole. The relative mass is the ratio of the mass of the element or compound to 1/12 the mass of carbon-12. Relative mass does not have units. There are 2 types of relative mass: relative molecular mass and relative formula mass. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. Which number represents 1 mole? A. 6.023 times 10 to the -23. B. 6.023 times 10 to the 23. C. 6.023 times 10 to the 26. D. 6.023 times 10 to the -26. The answer is B. 6.023 times 10 to the 23. Question 2. What is the molar mass of the element sodium? A. 11 grams per mole. B. 34 grams per mole. C. 12 grams per mole. D. 23 grams per mole. The answer is D, 23 grams per mole. Remember, the atomic mass or the mass number tells the mass for 1 mole of the element. Sodium has a mass number of 23, therefore the mass of 1 mole of sodium is 23 grams. Question 3. What is the mass of 1 mole of a substance called? A. Relative molecular mass. B. Relative formula mass. C. Molar mass. D. Moles. The answer is C, the molar mass. The molar mass is the mass of 1 mole of a substance. Question 4. Which statement is incorrect about relative mass? A. Relative mass for covalent compounds is called relative molecular mass. B. Relative mass for ionic compounds is called relative formula mass. C. Relative mass has no units. D. Relative mass has units of grams per mole. The answer is D. Relative mass has units of grams per mole is incorrect because the relative mass has no units. Question 5. How many atoms are in a sample of 65 grams of zinc? A. 3.012 times 10 to the 23 atoms. B. 6.023 times 10 to the 23 atoms. C. 3.012 times 10 to the -23 atoms. D. 6.023 times 10 to the -23 atoms. The answer is B. 6.023 times 10 to the 23 atoms are in 65 grams of zinc. The mass number or the atomic mass tells a mass in grams of 1 mole of the element. Therefore, 65 grams is the mass of 1 mole of zinc, and 1 mole of any substance contains 6.023 times 10 to the 23 particles.
We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Iri-e-learning.